this room is quiet.
Yeah.
It's so funny. For the director.
We got music. All right.
All right.
Can you hear me?
Loud and clear, Captain.
All right. So my name's Tim O'Sullivan. I'm one of the modelers that helped with the droid division, Huyang. We've got David Ferreira up here, also a contributor to this, and I'll break down where their contributions were as we go through the presentation here. But really, the real contribution goes to the guys that built it himself. I actually talked to David. David Corvovius is the guy who designed it for legacy effects for the film, and it was really interesting. I got to talk to him for about a half hour and hear a little bit about what it was like puppeteering them, the challenges, and how they actually get the droid, the initial stages of it. So they get it, basically, the digital guys they get a concept, art concept, and then they go ahead and start building some sort of digital model of some sort. But a lot of the model doesn't include the mechanics at some point. And one of the things that David said about Huyang is the most important thing. Okay, I got this model, but it doesn't have any character. I can't move the mouth. I can't. How do I bring him to life? And the number one important thing to him was actually, he said, you know what? If I'm really going to bring him to life, I got to do something with his eyes. I mean, if you light him up like C-3PO, it's just plain. Right? So he decided to do a modification. I'll let Stefan talk about that, because Stefan, later in the presentation, is the guy who did the code for the eyes that we have here. There's a few more designs in the droid division, but whoop. There we go.
She is not an acceptable candidate.
But yeah, you have to give credit to the guys that build these back at the industry, like Legacy Effects or Industrial Light and Magic. If it wasn't for them, we probably wouldn't be inspired to do this. And the way they brought this to life was incredible. He had to do it. He said that one of the things, I guess he was really curious in how we did the mechanics for this guy, because he is pretty fluid, very smooth. And that was the thing when he was puppeteering. He had to do it live. All the movements during the show he was doing it live, puppeteering. So it had to have a quick response. And I think we don't know for sure, but most likely Dynamixels that they had inside the original one to get that responsiveness. We could have done. I think we tested a couple servos, but high techs. But to me, I've been a real big fan of Reef servos. They're fantastic servos, pack a lot of punch, and you can get them really smooth with the system that we have configured here. So here's a breakdown of a lot of the contributors to this. Of course, I did the face, sculpting the face and the helmet, the torso mechanical aspect of it, which was based off of Jesse Marcelli's, I can never pronounce his C-3PO animatronic torso design. The only thing I really changed was how the torso fits on the actual mechanism itself. It had to match his torso. So I had to restructure some of that, because I had built the animatronic C-3PO as well. And so I was pretty familiar with it, and I knew it would work great for the purposes that I need to hear. I just wanted some left turn, right turn, forward and back to do that. But really, the toughest part, we'll get into that when Dave talks about the head mechanics, was the head mechanism within it. But as you can see here, Doug Olson did arms. Dave Mogg, as a lot of you know him from Droid Division, he did the hips and the torso. And then, of course, Chris Osborne did the backpack. And then I designed, Stefan worked on doing that. And, of course, there's Mel Matson. She does a lot of leather work for Wookiees and other things, and I was referenced to her. I did some of it, but the pouches, she's a great resource for that. She's got the patterns now. So for those of you
Nice.
that are interested in building a Huyang, she's a great resource to have those patterns, and she can crank them out for you. So one of the great things about this design with Droid Division, 100% of the proceeds for the model are going to the Grand Amara Foundation. And today, to date, we got raised about $5,592 for the Grand Amara Foundation. So fantastic achievement. So for those of you that buy them, thanks for purchasing the files. And
Yes, I would like to second that.
I'd like to see more out there. When we first did this, it was a tough decision. Dave was very interested in a static model, you know, but there's no, for me, it just personally, I had to do some sort of animatronic design. And I reached out to Dave because I know he's very good at CAD work as well. I'm mediocre in Fusion 360, but he's a master at SolidWorks. And we figured we'd combine our skills. I did the biggest challenge we had with the face, for example. I did that in ZBrush because it was very organic. We tried a few times. It was very difficult to try to model this face in Fusion 360, which would have been ideal. So when you do look at the model, it's got a little bit of it's not symmetric, but most faces aren't totally symmetric, so it worked out really good. It's a nice program for those that haven't worked in it. It's like sculpting with clay, pushing pieces out here and there to line up. And you can, as you can see here, what I did is we got some really good references, photo references from different shots. Dave's very meticulous about getting good reference photos. He spends a significant amount of time prepping up reference photos for all the models that you see on Droid Division before he even begins. It's like the biggest step. But having a front, a side view, and if you can get top, great. But the more reference photos you have, the better the sculpt's going to be. So we looked at it from a side view. You can see here the third picture there in the blue is actually my model overlapping the actual face itself. So we're pretty close, I think, when we did it. Some of the things it was really hard to see in the screenshots, some of the like the side greebles, and at first we just kind of took a guess. And actually, when the real close-up shots showed up, it looks like we nailed it right where it should be. As you can see, we looked at everything from the curvature. Some of the things a lot of people couldn't see is that curvature in his nose that he had. And we also pretty much got that down pretty good. So once you get this mesh put together, of course, when you export a model out of ZBrush, it's not always easy to work with a STL or an OBJ file inside of Fusion 360 or SolidWorks. It's pretty difficult. So you have to take this model, and you can see here.
Or the next one.
It's probably the next one. Yeah, you can see here that it's triangulated. It's got all kinds of triangles, and you can't really do much with it. I sent it over to a friend of mine, Sai, to see if she can maybe do something to fix it. And it's really difficult without having some converter that can actually handle it. Fusion can convert STLs and OBJs, but the more pixels and triangles that are in there, it overloads the machine, the computer, and it just starts spinning in a circle for hours. But anyways, I had sent this over to David, and David, I'll turn this mechanism over to you. And
yeah, sure. I think we all agree that not just the eyes of the character, John doesn't agree with me, but all the character driven by the eyes has to be driven by the motion of it. So creating a motion with a maquette like this is really difficult. So the more degrees of freedom you can add to that gives you more things to play with. So we saw and studied as much as we could of the footage and figure out what exactly it does. And we knew he had the head would pitch and roll and also have yaw so it could spin about. And Matt's been doing that now.
Yeah.
And then also he can lean his neck forward and back just like we can. We can dip it.
That's the slider on the front.
Yeah. So if you can show that, Matt. There you go. So he can dip his head forward and down. You see that a lot in some of the scenes in the ships. So so for movement, we probably got 90% of what they actually shown on screen. There was an additional degree of freedom that we thought was just like, we don't need to do that.
Yeah.
So the neck also had roll, which we thought
we found that after we did the design.
We
It's
found
like,
it after
well,
we did the design.
do
So
we go back?
why Tim reached out to me is because I did some work with Wally and my Rex droid, and we were able to do a pitch and roll system in that that allowed for that fluid movement to have that engagement. And he said, Dave, can you just put it in this? And I said, there's going to be some challenges, and one was space because of how the neck is relation to the eyes. So we started off with our servos in the front. You can see some of the motion there. And that we wanted to figure out what was going to give us the best bang for our buck, because there are many collision points with him. And I talk when parts hit parts as they're moving. So that was some of the things we prototyped and worked out for like the first few months. And that just allowed us to figure out where the best place is for wire management and serviceability. So as we went down the line, we started changing different servo locations and ended up, and we'll see in a slide later, where the servos are actually in the rear of the head versus in the front of the head, allowing for the eye mechanisms that these two worked on to be fluid with that. One of the challenges was in the show, you would think the neck rotation would be straight up, and it is not. It is tilted 30 degrees. So his neck rod coming through his neck is at a 30-degree angle. So we had to develop a way to rotate that so his head would rotate in yaw on a flat plane, and also maintain the angle. So that was a unique find we had to figure out. So that actually worked out well because it gave us more servo space in the end.
One of the things we just changed up just recently, I guess you hadn't seen it yet, but thanks to Michael Badley, who was visiting.
Mr. Badley.
We took instead of the little horn tip on there, that piece is all solid, big and round now. Just one big round piece, because I actually had a breaking point at that tip where it would snap.
Yeah.
But it really helps.
So I don't know, did you have a mechanism?
I got the neck side.
No, like the inside where the universal part is. Do we have a slide with that?
I don't think so.
Oh, that's okay.
The U joint? Yeah.
Yes. So how that works is there's a universal joint running right in the center of rotation, and we're pivoting off of a fixed post. So the fixed post goes through the universal joint, allowing you to pivot off of the fixed point, and then it just allows that movement to happen. So once we got to that point and figured out we had the space to use it, we knew we could continue on and move on to the next challenge, which is the neck actually pitching forward.
As you can see.
Yeah.
There's David playing with it. This is SolidWorks, right?
Yep. Yeah. So we were able to figure out he naturally keeps his neck at a 10-degree angle, and then everything from that point probably continues to about 20 to 25 degrees. So we wanted to just have more subtlety than anything else. So now we have a head, all the mechanics, everything's up top, and we have to pivot away probably 250 millimeters. So we have a big cantilever. So we wanted to make some type of gearbox going in that. So we utilized some off-the-shelf parts from Go Builda. So we have a Stingray gearbox in there. That's their brand name. And we're pivoting off, and you can see there, a fixed point. And that just allows us to take an off-the-shelf item that can pivot along itself. So it's mechanically stable. I think that's what, a 7-to-1 gear ratio.
Yeah.
So even a lot of movement on the servo, it's a small movement on the neck. So you can maintain that.
And we need a lot of torque.
You do need a lot of torque too as well. So that's probably a 500, no, for your imperial units, 500 inch ounces when it comes to that torque.
Yep.
What
you would see there is this part. I wonder if it shows from us. No. This part right here, as you can see, Normally, if you don't recognize it, this would be a big round gear all the way around. And what we did was cut it because we really only needed a certain range of motion on
Yeah, truly. Yeah. And they just allowed us to fit it in the space. So we designed the printed part to just bolt in to the natural mounting of the gearbox itself. So it lent to that too as well. And you can see the other servo hanging down is the neck rod. So that whole mechanism actually rotates in synchronicity with each other. So that allowed us to make a wiring harness that simply was just one harness that just moved with it.
All right.
But it's halfway down in his chest. So
Yeah.
which led to Tim designing the torso in a way for that to have
move.
room.
Yeah. I think my first design, I didn't even think about that hitting the frame of the torso mechanism, of the chest mechanism.
I think what was great about this process is for me working with Tim, it allowed us to take the time to prototype this out. And we went through about 5 prototypes
Yeah.
I have known many Padawans over the centuries.
to feel comfortable with it, because you can make something once and it works okay, but we wanted to stress out the failure points and make it as good as we can. So it allowed us to streamline it in a way where you can assemble it simply and service it at the same time.
Yeah, I think like I said, one of the things here's the torso mechanism. As you can see, I had to make a big gap in the center there so that neck mechanism isn't going to hit anything. And it's very similar. I used pretty much the same points that Dave has on the static shoulder, where it mounts to the shoulder. At first I was thinking we had to bolt his chest in or something, but it works out really, really good for, like, if you're going to bring it to a con or event. It's just you disconnect the plugs and you can lift it right off those pins. It's not going to jump off the pins, and with the weight of the head and the body, it stays on there really nice. But if you've never seen Jesse's design, the one on the right is for C-3PO. Same concept. You've got those 2 servos there that will tilt the shoulders left and right, and then you got the 2 servos on the top. On the sides there, that will give you that lean forward and then lean back movement. And then inside the bottom, underneath it, there is a servo for that whole rotation of the torso. And that's just sitting on a Lazy Susan bearing with a housing so that it actually rotates. It's really simple, actually. I just had to redesign it so that it actually fits on his leg mechanism. So we had to gut out some of the parts to fit that housing in there. When we did this, we didn't really give instructions to the group, because we figured that anybody who was going to take on a full animatronic is gonna have some sort of mechanical background. We really wanted people, because they don't do a lot of the animatronics in Droid Division. It's more the statics. But if they were going to take it on, it's more of a learning experience. We did put the step files, the CAD design.
Yeah, so we uploaded the complete assembly so anyone can download it in any CAD format or CAD program that they choose, and tinker and figure out how they could either reverse engineer it to their needs or make it better.
Yeah.
So
it was Jesse Marcelli already has the instructions for assembling this torso mechanism, this bottom part with the bearings and the servos. So if you are going to build a Huyang, I'd recommend going to his Thingiverse, download the design, and inside the design he did a beautiful job of providing instructions for all the parts and pieces that you need to build that mechanism listed in the Droid Division files. So one common mistake that I've seen is there are the 60K servos in that mechanism, but be very careful when you order them, or if you decide to, make sure you get the robotic servos. They look a lot like the ones you see here on the left. However, they have a little shaft on the other side of where the servo horn is to guide it. If you buy these and try to put it in that housing mechanism, they've got a little, see the raised bump on the front? It won't fit in the housing. So these are shaped a lot. They're basically square. And when you put them in there, they fit really nicely. You've got to take some of the screws out and rebolt them through the body itself, putting it in the housing. But it's pretty simple.
Good tip.
Yep. So for the operation system, or what I decided, there's a lot of different options. There's some other people starting to build these now, and they're choosing different routes. I'm a big fan of the Kyber system, and some of you have them in your droids, but because of the fact that I can tie into that Maestro, and as you know, Maestro with the program down here, you can see the control center. You can really get these servos pretty smooth. And combined with, like in the head, we put reef servos in there. They're very quiet, very smooth servos. They pack a lot of power, got a lot of torque, and I've had any problem. You could still go with, I think in the group we listed some alternative servos.
Because the head naturally is very light. It's not moving a lot of mass up above it. So you could get away with probably a 25 kilogram motor or a 200 inch ounce motor.
But what you'll find is it's going to be very loud. I had originally, like for the monocle up there, can you drop it down for me real quick?
The only time you are wasting is
First button on there. There you go. It goes really smooth and really quiet. That's a micro reef servo. It makes a little noise, but the high tech was just screaming loud when I did it, and I got rid of it.
There's a difference when we're making our robots. They say we want those robotic sounds. We don't want those sounds that they're screeching. Ooh.
Yeah.
Well, we prefer that, not to have that. But if it works, it works.
Yeah. But the other great thing about with the Kyber, I had to reach out to Stefan because it was something different that we don't normally do with the Kyber is the eyes. I wanted to be able to control those eyes using the Kyber system and one of the sticks. As you can see, you can make them squint. You can control the squint or the blink. His blink is in a loop, but I wanted to be able to give it some expression. I've had him at some events. It's great where people are just, he goes in an auto sequence mode where he'll just run and they'll stand and look at him. And then all of a sudden I can override it with the control and look at him. And then I start squinting at him. And I've had a few people, he was at the Center of Science and Industry. We had him on display. And I saw people jump back like, hey, he's looking at me. And then they're moving their head and it's following at him. He's looking at his wife going, he's following me, you know, and they didn't know. And then finally the wife sees me and smiles and she sees that I've got the sticks. So it's fun. But with that, let's talk about this eye design that Stefan came up with. You know, he reached out to me and said, get this and this. I said, okay. So
finally, after saying it, guy, easy part. So Tim asked me to do the eyes. Quite easy code, I would say. Not that hard. The eyes are the same. So it's just a matter of doubling the wiring to each LCD. I think Tim got an insight that we did right on the eyes.
Yeah, I think we got really close.
So at first we tried to do the grill in the eyes itself, the design. Then Tim came with the 3D printed part. So it's really a yellow round thing, that's it. And the code to get the PWM signal to do the eye blink and a random loop that do the blinking on different timing. So that's about it for the, like I said, I got the easy part and I was most of the time moral support for Tim.
Yeah.
Stefan, I blew something.
But what's really neat is that he for this eye design, if any of you are making or creating a droid that maybe you want to add some character or similar eye character, he's got it a program with the Kyber that you can change the colors too. So you don't have to stay with yellow. Say you want to do the similar eye feature in your droid, you can easily just select a color or
it's
I think you punch in the RGB colors.
RGB
and
color.
You don't have to mess with the code. It automatically will flash it, and then there's your color for the eyes. It's great. So, but yeah, that's pretty much him. We have the head is very. We did the head with some magnets, so quick access if you want to get inside there to.
She is not an acceptable candidate.
You can see the mechanism working. But yeah, it's trying to get back on. There we go. But fairly fun build. It was a great challenge and pretty pleased with the results. But any questions? Oh, no questions.
Perfect. You did so well.
All right.
Yeah.
All right. What's that?
Yeah. Well,
Yes, I would like to second that.
yeah. There you go. So,
Yeah.
I think what was great was the amount of people involved in this charity build. There was more than that were on that list. There was probably
more.
10, 15 people that helped contribute to the design of the character, to the functions all the way around. And there's plans to do a version 2 of it. I know Dave wants to revisit it at some point with free time, but the fact that we put this together in 4 months or something like from start to finish, and then it was out to the group. It went really quick. And yeah,
it takes a team.
It does take a team.
There's so much talent in this room, and combined, it's amazing what we can do and come up with. It's great. So
what's great is that you can check each other out.
Yeah.
Like, you sure you want to do that?
Yeah.
Second guess.
I had a question about the animations themselves. Did you just program them and see what happened, or did you move ahead, take stock of the servo settings, and then go that way? How did you get some of these nice animations?
The movements. Well, right now Matt's driving him, but it was just a matter of smoothing the servos and setting limits on those servos, the maximum movements, and then putting a stop to it so it doesn't hit anything. And now, what's up? On the Maestro, yeah. So now, I mean, anybody can grab that and drive it. You're not going to break it. It's gonna stop before movements. Yeah, right at the right place. So, yeah, I could let a 6-year-old drive it, and they couldn't break it. So
Maybe.
yeah, maybe.
So we're using a feature of the Kyber that pass through. So each channel can be tied to one or many channel of the Maestro. So Matt is moving one of the stick. It will adjust the output of the Maestro to 1, 2, 3 servo, depending on your needs. So this part is used. Then we have automatic mode that kick in. And when you it will start
flip the toggle.
by itself,
He's
it
on
will
automatic
restart.
now.
Yeah.
He's not driving it. So,
But as soon as you take control of the sticks, it will bypass and do its stuff. Yep.
yeah. So you got to go in and build a full sequence of how you want it to move when you're not using it, and you save it. And then when you flip that toggle switch, say you want to go someplace, but you still want to move it around at an exhibit or something like that, and you don't want to drive it anymore, just flip the switch and he's good to go, and he'll start running on his own. So
I was just wondering, if you saw the you guys in Jurassic Park, they have the old stop motion guys.
Yeah.
They would move, like, if you were spinning, they would keep all the movements, and then you could just throw it at the servos and you could spin. I was wondering if you're there yet.
I think
Working a version of hybrid and stuff, do that bus report.
yeah.
Don't put me on the spot.
Yeah, that what that's going to do is like you can get go ahead and move them around. What he's hoping to do is say, like, instead of getting in there and moving a bunch of sliders around and saving that as a sequence, you were hoping that you'd be able to drive him for a while the way you want him to move.
Yeah. This also takes into account of having all your movements pre-programmed and your smoothing done and any blending in place. Once that's there, then you're going to have the opportunity to perform it as a character you want and repeat it every time.
Yeah.
Sir.
Control system, can you manually move the servos into the correct position? And that will do that?
If you have the Maestro app open, you can see the movement as it's going. If you wanted to see the PWM signal.
The PWM signal, you would need to grab something that would grab it and display it.
Yeah.
But no,
there is no feedback on the servo, so it's not like a bus servo that you can where it is exactly. This kind of servo just go where you tell them to go. Yeah.
Mhm.
Yeah.
Yeah.
With sliders, you bring
Alright.
it where you want it to be.
Oh, it's not on this one.
Yeah, but you can see them on the bottom right. So you have the sliders there,
Yeah.
and you can move each servo at the position you want. Then you click record to get this position set.
Yeah.
Mm.
Yeah, the Maestro is beautiful. Like I said, you can go in there and set your acceleration, your speed. You want the servo to move, and then establish a set range, and you save it. And then now that's it. So now you want to go do your animation. And then, like you said, you slide that where you want it to. You want to turn ahead, and then you hit save. And then you want it to look up, turn it, look up, hit save. That's it. But what's like we were talking earlier, what's really going to be nice if they can get when they get the S bus pass through and save the features and the movements, that's gonna take it to a whole new level. It's gonna be great.
So what do you guys think about Huyang? Yeah. And
I protest. I have a lot of work to do.
And honestly, the proceeds will continue to go forward to sponsor the Grant Imahara Foundation until the end of time.
Right.
So, all the people, anyone who buys the files from Joy Division, all that money proceeds still go to Grant Imahara Foundation.
Yeah.
So the total will keep ticking.
Yeah.
So.
And anybody has questions in building it, drop me a PM on Facebook or whatever, and I'd be happy to answer your questions and help you out. What's that? Tim O'Sullivan. Yep.
Initially, there were a lot of questions, and for myself at least, I attribute that to seeing such an advanced build and like really amazing animatronics. It feels, I can really see that role in X-Men. That's all the motion there. So from there to like RX or Huyang, I think there's a big gap in terms of like motion and animation and all that stuff. So what would be a good next step at project or exposure to start moving towards some of these more like under motion things that is interesting?
I think just anything you want. I would just get a Maestro, a Kyber, and an RC controller and play around. And that it doesn't even have to be complex. That's the system here. It's just a Maestro, a Kyber, and a servo, and play around with the movements. And you could do anything with it. Yeah. You can incorporate. Yeah, you can incorporate the same system. It may look complex, but it's really not. You can incorporate that to any design. I've done it. I've used it on. I've done a couple other animatronics. Animatronic Grogu, same system. Kyber, Maestro, and a controller, and it's very fluid movements on them. I did a Babu Frick, same thing. C3PO it's not Kyber, but it's the Maestro because he's a little different. Andrew here did some coding that he's actually has a body recognition system, so it sees people and he'll turn the body and start talking to them. It's a little bit more advanced, but this is an actually good simple build to learn from. That's why we like I said, all the CAD files are there, and if you're familiar with the Kyber, and you don't even need to be familiar, you can use the same configuration. I think, like I said, you want some questions and how to hook it up and connect it. Any one of us can help you.
Yeah, and if you have a question on the Kyber itself, feel free.
Yeah.
We're here.
Yeah. There's going to be additional Kyber talk today or tomorrow, or is it Sunday? Sunday. Okay.
Yeah.
So.
Are you doing a panel? Yeah. So, anyway.
Awesome. Awesome.
Feel free,
All
we're
right.
here.
All right. Thank you, everybody.
Yeah.
All right.
Good job.
Yeah, good job. The what's that? Somebody mentioned that, but I didn't feel a need. Yeah, the problem, I really thought about